Hi there, and welcome to Curious About Innovation from the Glasgow Science Centre. My name is Katie, and usually you'd find me in the planetarium here at the Science Centre. But today I'm really excited to be introducing you to a David Elder lecture sponsored by the University of Strathclyde from planetary scientists Aine O'Brien and Luke Daly, who we actually are going to have here with us to chat and answer all of your questions. But before we do that, we've got a wee video for them introducing us to a very exciting space news topic that literally hit UK soil in the last month. So let's have a wee look.
Hi, I'm Aine O'Brien.
And I'm Luke Daly.
And welcome to our David Elder Memorial Lecture. We are planetary scientists from the University of Glasgow, and we're thrilled to be here chatting to you today from Luke's garden.
Now, a planetary scientist is a scientist that studies rocks from space. And in this lecture, we're going to be talking to you about a really special event that happened just last month, where a brand new space rock arrived on UK soil. So as planetary scientists, we study rocks from space and look out into our solar system to try and understand some of the big questions we have about how we came to be. One of the biggest ones is, how did our solar system form? How did we go from a big ball of gas and dust, collapse that down into a dense pocket where it was so dense and so hot that nuclear fusion started, forming our sun with a swirling disk of gas and dust around it? How did that swirling disk of gas and dust clump and come together to form bigger and bigger bodies like asteroids and eventually planets? And space falls out of the sky at us for free all the time in these beautiful events which we call fireballs. Now, a fireball is essentially the evidence, the light in the sky of a rock falling through our atmosphere and burning up as it goes. And if we're really lucky, a little rock will survive that fiery transition and land on the ground in something that we call a meteorite. Now, meteorite just means a rock from space that's now on Earth. And there are three main types of meteorite. There are iron meteorites, stony iron meteorites, and stony meteorites. And they come from various objects in our solar system. And so by studying them, we can understand different portions about how our solar system came to be. For example, iron meteorites come from the core of a planet. So when a planet gets big enough, its whole body melts. All the heavy elements like iron and nickel and other metals sink to the bottom to form what we call a core. This core is made of iron nickel metal. It produces our magnetic field, which keeps us safe from harmful radiation. And the great thing about iron meteorites is we can learn so much about our own planet. We can't get samples of our own core. It's so deep, it's so hot, it's so squishy down there, you really can't drill that deep. And so iron meteorites represent a window into what our own core might be made of and what it might look like. Another group of meteorites called the stony iron meteorites are evidence of some of the most cataclysmic events in our solar system when two planets collide. They are essentially made, as the name suggests, of bits of stone, a bright green mineral called olivine, and bits of metal, mostly iron nickel. And they represent what happens when you have a core, that iron nickel metal core, and the outer crust or mantle of a planet merge, producing this beautiful patchwork texture of stones embedded in metal. And then finally, the group of meteorites that myself and Aine spend most of our time working on, the stony meteorites. These are split into two groups. As the name suggests, they're made of stone. There's achondrites, and achondrites come from large planetary bodies that have formed that core, but these ones, instead of coming from the center, come from the very outer crust. So these represent samples of volcanic activity or asteroid impact on other planets like Mars or our own moon in the form of lunar meteorites or other large asteroids that have formed this core mantle crust structure. And so by studying them, we can understand what volcanic activity is like on other worlds in our solar system. And finally, the chondrites, which are my favorite. These are the oldest rocks in our solar system, the oldest rock you will ever hold. They are 4.5 billion years old, which predates the Earth. And all the minerals inside them essentially formed within the first few million years of our solar system. And so by studying them, we can understand what our solar system was like before there were planets. So a meteorite, like we discussed, is just a rock on the ground. So a meteorite is a space rock on Earth. A meteor, or if it's big enough, a fireball, is just the light in the sky as it streams through the atmosphere, and that rock is just getting really hot on its outside, burning up, turning into a plasma, and just kind of burning up. And a meteoroid is that same meteorite on the ground, but it's just in space. It hasn't landed on Earth yet. And there's this fun change in the way we talk about objects, that when they're in space, they're meteoroids. And after they've gone through their meteor fiery transition through our atmosphere and landed on Earth, they become a meteorite. So meteoroid in space, meteor, light in the sky, meteorite, rock on Earth. And these meteorites can tell us so much about how our solar system formed. And so relatively recently, we've developed new ways of trying to track them as they fly through our atmosphere in those bright meteors or bright fireballs, to find out where they land and also find out where they came from in our solar system. And that's why camera networks such as the Desert Fireball Network in Australia, but also the UKFAll Network and UKFall Alliance in the UK have been set up in order to do this. And the idea is very simple. You go into the middle of nowhere and you set up a camera. And this camera will take continuous pictures of the night sky every 30 seconds or so. And you set out lots of them so they all can see the same part of the sky. And then, if you're really lucky, several of your cameras will see a bright meteor, in this case, really bright, which is called a fireball. And because lots of them saw the same fireball, the same event in the sky, we can figure out where it was in the sky. We can triangulate it. We can use all the observations from all the different cameras and figure out where that fireball went through our atmosphere. This is an event we captured in Australia, and we predicted that there should be a meteorite landing in Katitanda Lake Eyre, the largest salt lake in Australia. And so the team got sent out to search this salt lake, and very luckily, Professor Phil Bland dug deep into the dirt and found a nice pristine meteorite that we had seen to fall, and was able to pull it out of the dirt and bring it back to our labs to study, which is just amazing. It shows that we can set up cameras in remote locations, take pictures of the night sky to see these fireballs that drop meteorites, and then go collect meteorites and figure out where they come from. And that orbit, that figuring out where they come from, figuring out where these fireballs are coming from in our solar system, is really important. This is a graphic of all the fireballs we've seen by this Desert Fireball Network of cameras. The teal dots are fireballs that come in to hit the Earth, which is just that third purple line rotating around the sun. The orange lines are their orbits, and we can start building up a picture about where material is coming from in our solar system and where things are being delivered from. For example, the Geminid meteor shower is coming in, that big pile of teal dots is hitting Earth right now. So we can say, wow, the Geminid meteor shower drops a lot of meteorites on us, which is really amazing. Now, the UK is very different to Australia. The UK has lots of dark green forest, boggy marshlands up in Scotland. And so it's a lot harder to find a little black rock, which is what meteorites look like, on dark green grassland or in forest than it is in Australia, which is a barren, red, lifeless wasteland. And so little black rocks there stick out like a sore thumb. You also have a lot of clear skies, which is really wonderful for imaging, whereas we have a lot of clouds in the sky, which means we can't image all night through. But we can still see fireballs. We've started setting up our camera network. We've got plans to expand it up through Scotland, particularly into these dark sky parks in Scotland, which just have the most beautiful night skies. You can see just a sky full of stars. If you ever have the chance to go up, I thoroughly recommend it. And so when the night sky is clear, we can see these brilliant fireballs, these amazing meteor events, and I hopefully track them down to the ground. And so the last 5 years have been building up to a really special event where we saw a bright fireball on the 28th of February, 2 months ago. This thing flew through the night sky, bursting as it went in these bright flashes. And we immediately thought there is every possibility that this thing dropped a space rock. And it was captured on all the cameras in the UK Fireball Alliance, from us at the UK Fireball Network to the Frippon Network to All Sky 7. All the networks captured this thing. And so we got amazing data to figure out where it landed. And that led us, by mapping out its trajectory, to a little Cotswold town called Winchcombe. And I'm going to let Anya tell you the rest of the story.
On the 28th of February 2021, the Wilcox family were having a relaxing evening in their home in lockdown. They heard a loud noise and sort of thought nothing of it. In the morning, they opened their front door to find a great big pile of black dust on their driveway. They'd seen on the news that there had been this fireball over Gloucestershire. They'd seen people like Luke, who you've just heard from, talking on the news about if you lived in the Gloucestershire area, if you went outside and you saw a black rock, there was a good chance that would be a meteorite. Well, when they came out of their front door and they looked on their driveway and they saw this great big pile of black dusty stuff, they knew that's what it must be. The Wilcox family got in touch with the UK Meteor Observation Network, who were able to look at the pictures that the Wilcox family had sent, and there was something good there. So Richard Greenwood from the Open University, who's a planetary scientist like Luke and I, lived quite close by, I think in Oxford. So he was able to drive over to the village of Winchcombe, where the Wilcox family lived, and straight away he recognised this black dusty stuff, kind of looked like crushed coal. He knew straight away that was a meteorite. This family had scooped up a lot of the dust off the driveway pretty much immediately once they'd seen it the next day. So not even maybe 12 hours after the meteorite had fallen. So cue this massive frenzy of people like me and Luke and lots of other planetary scientists of, oh my gosh, not only was this beautiful fireball seen all across the UK and even in Europe, but we've actually got a piece of meteorite as well. Furthermore, we'd seen this fireball and it actually looked like it had exploded into lots of pieces. The fact you could see it from really far away and you had these big, bright kind of explosions made us think, what we think is this meteorite kind of split up in the sky. And our clever mathematicians who used the fireball network observations were able to kind of constrain where this meteorite must have sort of split up and fallen. So there was something like 15 or 20 of us from Glasgow University, from Manchester University, Plymouth, the Natural History Museum of London, Imperial University, lots of different universities across the UK. Our scientists came together, got a team together to travel from all across the UK to search the Gloucestershire countryside for other fragments of this meteorite. Lots of members of the public were calling in, sending photos saying, hey, I think I found one. But we had to be sure, make sure there wasn't going to be any other bits we missed. So we got a team together of planetary scientists to basically look in the zone where we were pretty sure a meteorite would have fallen if there were any other fragments of this big stone. We think the big stone was about 100 kilos when it hit the atmosphere, and we think something like a kilo of it, albeit very fragmented, fell to the Gloucestershire countryside. So Luke and I and 10 to 15 other planetary scientists between us spent about 5 or 6 days searching the Gloucestershire countryside to see if we could find any more little black rocks. How do you search for a meteorite? Well, these things that we knew were going to only be less than fist size or as small as your fingernail or even smaller than that. So what that involves is basically going in a big long line, probably at least 2 meters apart, and walking in a straight line along a field and looking about 4 feet ahead of you and scouring as you go. Now in Gloucestershire, it's a very sort of agricultural area, lots of countryside, lots of people with farm animals and lots of sheep and rabbits and things like that. And unfortunately, as much as it was lovely having all these animal fields, the feces or the poo of sheep or rabbits, they can be very easily mistaken for meteorites. So I spent a lot of time going up and down, scouring fields, getting excited, thinking, oh, I found a meteorite. I found a dark, black, shiny thing. And it was poo. So Luke's girlfriend, Mira, had come down to Gloucestershire with us from Glasgow, and she was working from home in the hotel during the week, but then joined us on the Saturday when we started searching. And she was a bit nervous. She's not a planetary scientist. We went to a field in the grounds of a gorgeous country estate in Gloucestershire that day. We were there at about 8:30 on a very cold Saturday morning, having had several days at that point of really not having any luck in our search in the field, thinking we're not going to find any more. we were going up and down this big sheep field, and she kept saying, "Oh, I think I found something. Oh, is that a meteorite?" And Luke would say, "Sadly, it was poo." Now, after about an hour of this, she was starting to worry and feeling a bit guilty that she kept stopping the line, because we all walked in a big long line. And she looked and thought, okay, I've seen about 8 poos now, but I've seen a black thing there that it really does look like a meteorite. It looks like a stone. I don't think that's a poo. So she sort of thought to herself and was like, okay, I better ask just in case. And she says to Luke, "What about this? Is this one?" And straight away, Luke said, "Yes, that totally is a meteorite." Our team, it was just the Glasgow team at this point involved in the search. And what she found was a beautiful shiny piece, about 300 grams, embedded about 5 centimetres into just a lovely little grassy field. We were so excited. We were jumping up and down in the air. All we wanted to do was hug each other, but obviously, other than Luke and Mira, who were together and therefore a household, the rest of us couldn't, but we were just, it was such a wonderful moment. And the most amazing thing about this meteorite is not that it's just, it is the first British meteorite in 30 years, which is an amazing achievement in itself, but the actual type of meteorite that it is super exciting and interesting to meteoriticists and planetary scientists like me. This type of meteorite that we think what we call the Winchcombe meteorite is what's called a carbonaceous chondrite. What that means is it's basically packed full of carbon. Why is that interesting? Well, life as we know it on Earth is packed full of carbon. Your DNA, every molecule inside of you pretty much is a carbon-based molecule in all your cells and things like that. And these meteorites, carbonaceous chondrites, we think might have been one of the sources, or if not the source, of the Earth's carbon, of the Earth's building blocks for life. These meteorites have amino acids in them. They're the molecules that make up DNA. And not only that, these meteorites, their minerals have also got lots of water in the minerals. So maybe even meteorites like that brought the water that we need for life on Earth. And the asteroid that carbonaceous chondrites have come from, or several asteroids out in the outer asteroid belt, these are really interesting because they're packed full of these organics. We've even spent billions of dollars, the US for NASA has spent billions of dollars sending spacecraft to asteroids to collect this material, and we've had a piece on Earth that's fallen and that we've managed to collect thanks to the UKFAll network. It's a wonderful achievement. I'm so excited to be part of the Winchcombe science team. I've actually just spent the last few weeks in East Kilbride in Glasgow crushing up a really tiny piece of the Winchcombe meteorite and then dissolving it in lots of special chemicals. The point of that is to try and collect all the organic molecules. So these are the things like amino acids that we think should be in this meteorite, to then see what it's made of, what organic molecules are in there. This asteroid that this carbonaceous chondrite will have come from is probably older than the Earth. This thing formed right at the beginning of the solar system. It's going to tell us loads of interesting stuff about how the solar system formed and how on Earth we got the ingredients for life as we know it. So that's why the Winchcombe meteorite is so exciting, and why the UKFAll network, which has only been set up in the last couple of years, has already done such amazing things for science in the UK.
Wow, that was a pretty exciting lecture that we had there. I am really excited as well that we have those planetary scientists with us today. So we have Aine and Luke. Would you like to introduce yourselves? Hi.
Hey, I'm Aine. So thank you so much for inviting me here today. I'm a final year PhD student at the University of Glasgow, and I'm studying organics in meteorites from Mars and elsewhere in the solar system.
And I'm Luke. I'm a lecturer at the University of Glasgow, and I'm also a planetary scientist. I co-run the UKFAll network, which we heard about, and I also study meteorites and try and tear them apart one atom at a time to find out what the atomic level information they have in them can tell us about our solar system when it first formed, when our sun first started to shine.
We definitely have the right people here today to talk about meteors. And we have some YouTube comments. If you are watching live on YouTube, please do put your comments and questions in there, because we really have these experts here and we have them to answer all those questions. So let's get into it. First one up is from Nina Needs Space. And they ask, in the same way we've identified falls from objects like 4 Vesta in the past, will we be able to identify the source of this meteorite?
Shall I take that one on you? I think, yeah. So yeah, absolutely. That's what we're really hoping to be able to do with this meteorite. The great thing about it is we have, I think, like 13 separate observations of the fireball from lots of different sources. So we have a lot of data and a really nicely constrained trajectory, which really helped us get the meteorite on the ground and find it, but also is able to help us track it back into space, out into our solar system, and figure out its orbit. Right now, what we know is it comes from literally the outer edge of our asteroid belt, sort of like nearly out to Jupiter, but between that Mars and Jupiter zone. And what we're literally, as we speak, some of my colleagues are running what we call clockwork models. So they're taking it back in time, millions and millions of orbits, millions and millions of years, to try and see where that orbit becomes stable, and then what asteroids are floating around in that same orbit or in that same region of space. And so we're hopeful when the results of that come out, we'll be able to point at an asteroid and say, that one is what Winchcombe came from, which would be really, really cool. And it's basically exactly what, as Aine kind of mentioned in the talk, folks like NASA, folks like the Japanese Space Agency, spending billions of pounds to send probes to these water-rich asteroids to bring material back. We have a fragment of a water-rich asteroid and hopefully be able to do the whole thing in reverse for it's not free, but it's substantially cheaper.
And so can you figure out all of that just from the photos of and the angle that the meteorite comes down?
Yes, yeah. In fact, I believe there was a recent publication that I think that might be what Nina's referring to, that some of my colleagues actually used the fireball camera data or similar data to figure out that some of these meteorites that we have on Earth that look very similar to this asteroid Vesta actually have a correlation with their orbit. So they figured out that the orbit of this fall, as it came in, it was one of these meteorites that we were pretty sure came from Vesta, but they could figure out its orbit and say, no, for sure, this thing came from that asteroid, which is really cool. And like, it's really nice to have that proof that these meteorites come from this particular body.
That is absolutely incredible. I do not even know what kind of mind you have to understand that. We got another question coming in now. And it is, what happened to the dust that was found on the Wilcox family driveway?
Well, a big part of it was Luke on his hands and knees and a couple of our other colleagues for days on end with tweezers picking up as many tiny bits as they could, because this stuff is so valuable. Every gram, every fraction of a gram counts when it comes to samples as precious as this. So even though it's smashed up, it's still really useful to scientists like us. So yeah, it was a case of using tweezers, using gloves to just pick up as many tiny bits. So yeah, Luke, I think were you picking up bits out of the grass as well and just trying to find as many, smaller than a millimeter little pieces you were picking up by the end?
Yeah, pretty much. Yeah. I realized that the thing had like shattered into a million pieces and bits had gone everywhere. And so one of the things, there was like sort of 4 walls around the garden. And so I was like, maybe they hit the wall and dropped down. So I was going through the flower beds and found a few quite big pieces as well after picking up all the millimeter sized bits.
That's fantastic. I actually saw a photo and it looks like it left like a black mark on the driveway.
Yeah. And you know what's amazing? Not only is the stone that Mira found, the piece that you saw in the little video there, that's gone on display in the Natural History Museum. But not just that, we're hoping that a piece of that driveway might be going on display as well, with any luck.
That's
it made a tiny crater, like a 5 centimeter dent.
Oh my gosh.
Yeah, we've got a fresh crater in the UK.
Amazing. Let's see if we've got some more YouTube comments. Oh, it's not from YouTube, but it is another question. How long will it take to get data from the meteorite?
So we got data almost immediately. So one of the things that happened straight out the gate which is really exciting, is one of the people at the UK Meteor Observation Network also had a spectrometer next to his camera. And so he was able to get the spectra of the fireball as it came through, which gives you an idea about its chemistry. So before it even hit the deck, we were kind of had a rough idea about its chemistry, which is awesome. Within about a week, no, within a few days, a fragment had already been sent to the Open University, and we had oxygen isotopes, which is one of the key bits of information you want from a meteorite to be able to classify it. What's the abundance of different weights of different types of oxygen, basically. And we're hoping most of the analysis will be done within the next 6 to 12 months. There's some really cool stuff that I'll let Aine talk about that's happening now, like, because some stuff has to happen immediately, because, well, I'll just let you talk about what you've been doing the last few weeks.
Yeah, Luke and I were literally in a meeting this morning going through the data. So that little time lapse we saw in the video of me looking like the Michelin Man, because I was in the lab with a puffer jacket under my lab coat, because this was in March when it was snowing and the heating was broken in my lab. And this was doing an experiment on the meteorite at the time. And it was really urgent, because the stuff I study are these organic molecules. So these are these building blocks of life that we think meteorites like this might have brought these building blocks to Earth. And because Earth is packed full of molecules like this, the longer that these samples stay on Earth, the quicker or the more easily they get contaminated, basically. Even if they're just sat in a vial, even the atmosphere can do it. So it's super important to get these experiments done as quickly as possible, even if the heating's broken. So I was first couple of weeks, as soon as we got back from Gloucestershire, a little bit sleep deprived, straight away doing an experiment to basically try and dissolve any molecules in there that were kind of carbon based. And then today we're getting our first glimpse at the data that's come back, which is looking really exciting. There's some pretty interesting looking molecules in there. Definitely pretty organic rich in meteorite, as you would expect. That's why it's this kind of black meteorite, or one of the reasons anyway. So we started getting data back from the sort of these experiments that are really crucial to do quickly. Another kind of side that we need to do soon, that started already, is that we've done the oxygen isotopes as Luke measured, but there's also other isotopes that let us actually work out how long it was actually floating around in space after it had been chucked off this host asteroid. And that kind of blows my mind, that not only can we kind of tell what kind of meteorite, what kind of asteroid it came from the isotopes, but we can also use other isotopes to say just how long it was sort of floating around until it randomly hit us on Earth. Like, I just think that's amazing that different chemistries happen just from being exposed to the sun, basically, and other sort of cosmic rays, and they basically just interact with the atoms and make little cosmic signatures or fingerprints, if you like. So yeah, and that has to happen really quickly, because again, the Earth's atmosphere just interferes, and that gets annoying and interferes completely. So lots of exciting stuff happening, and yeah, it's just been amazing to be a part of, and data's coming thick and fast, so we've been very busy.
Yeah, the entire UK community is basically really engaged with this, and we've all kind of clubbed together. Every lab that wants a bit is getting a bit, and we're just throwing all the toys at it. In terms of the question about how long we would get data, so most of it's going to be happening in the next, like, very rapid characterization, but there is one experiment that's been proposed that's going to last 100 years, which is awesome. So we'll all be long gone by the time we get results of this. It's basically, they're going to put little bits of it in different atmospheres. So one's going to be in a vial, completely sealed in a vacuum, so basically nothing can touch it. Another one's going to be in a nitrogen atmosphere. Another it's going to be in an argon atmosphere. And we're not going to open it for 100 years. And then the scientists in 100 years' time are going to open that up and see if anything's changed.
Amazing.
So I really like that experiment. So we're going to be learning science about this rock for generations now, which is cool.
That's so exciting. I really didn't think that you were going to get information so quickly. And that's really great. And especially, like, I was just watching that video and that story of you guys finding it. It must have been so exciting to just come across that.
You have no idea. And not only that, like, it would have been amazing anyway, but it being the early March after a year of lockdown, and obviously us here in Glasgow, like, we really have had the restrictions more than, a lot of people. So to have got the health and safety approval, and I definitely have Luke to thank for sorting that with all the upper echelons at the university, to be allowed to travel. Obviously it was essential. Like, this is, as you've heard, incredible science. But yeah, to have done it at any time would have been amazing. But it was really just amazing to be a part of it at a time when, you wouldn't have been allowed to travel more than 5 miles, let alone the other side of the country, to be out and about. And we were going on people's land, and people were so gracious and so welcoming, which I was so worried about, because it could have been a bit scary, if a complete stranger knocks on your door and said, "Please, can I search your garden for a black rock?" And you're like, "What are you doing here?" There's a Glaswegian accent, all this sort of thing. And like, what's going on? In the middle of obviously a national lockdown, but everyone, was so welcoming, so kind-hearted. Every single piece that was found by the search team that was donated to the museum and all this kind of thing, and it was just lovely from that perspective as well. I guess, would you agree, Luke? It was just made it so much better by that kind of sphere of just, except the pubs were shut, it would have been great to go for a beer.
yeah like I said, you, like Aine said, the feeling of that about this is just unbelievable. I still don't really have a way to express it in words properly. If you'd planned a fall of a meteorite on UK soil, apart from being in the middle of a pandemic, this would be what it is. You recover it really fast. It's a really rare type. You have a really well constrained orbit. You can get into the field safely, search, find some stuff. And yeah, kind of on the flip side as well, this has been nearly 5 years of folks with these camera networks all starting to come together, realizing what everyone's doing, figuring out how we can share data. And so I still don't think I quite believed that we got it, but we did. So it's there, it's in the museum. But yeah, it's an amazing feeling. There's all this hard work from loads of people around the UK, testament to what you can do when you all just come together and work together, of the great stuff you can get done. Yeah.
And all being well, hopefully pretty soon there'll be a piece coming to the Hunterian in Glasgow as well. So fingers crossed. I think it will take a bit to get all the displays and stuff sorted out, but because obviously the big part we played in that, so it should be very exciting.
I will keep my eyes and ears open for that. That sounds really, really great. We've got another comment coming from YouTube. And this is from Derek Sherlaw. If finding meteorites of this size around the world is fairly uncommon, has there been much international interest in the Winchcombe meteorite? Have you become stars because you found it?
So in many ways, Winchcombe was also a global event. So the UKFAll Alliance, which is the network of cameras that work in the UK, also have these wonderful international partners like the Global Fireball Observatory in Australia, who work with the Desert Fireball Network. There's the SCAMP network in France, the Frippon network in France, and then a bunch of networks in Canada. And they all helped us figure out where this thing landed. So they threw all their models at it. So as much as it's a UK success story, it's a global scientific success story. So yeah, loads of people have been messaging us saying hey, I have XYZ toy to do XYZ measurement, would love to get a bit of it. And yeah, if there's stuff that we've not got covered in the UK, we've been sending stuff out to folks to do the thing that they do. So yeah, got a lot of people very excited, both in the UK and around the world.
And in terms of sort of beyond the kind of scientific side, the kind of media side has gone bonkers as well. The sort of media circus in the first few days was incredible. The Wilcox family were just so gracious and did just so many interviews. Luke, I think, had about 9 interviews in the space of about 2 hours, and it was lovely. And then it made news all over the world, and it was just lovely. There was so much excitement about it, and it's just been quite a uniting thing, really. People just enjoying this sort of little extraterrestrial visitor we've had, especially at a time when there's not that much to have been excited about in this last year, but people have. In fact, one of the comments that was made by one of the families was what all the good that science has done for people in the last year, and they kind of wanted to give back by kind of getting involved in this and saying, look, thank you to scientists, look, see what they can do. And so there is this kind of acknowledgement now as a result of the pandemic more than ever that, look, we're more at the forefront of people's kind of, I don't know what the word is exactly, but people are just kind of more acknowledge us, and people are excited about it. And it feels like perhaps that's an element of why there really was this just pure joy that it's something to be excited about, and there is this real acknowledgement of what good scientists do for humanity, you know.
Absolutely. And you mentioned something there about people wanting to get involved. Is there a way that, me sitting on my couch at home can get involved in the UKFAll network, or, anything like that?
Yeah, there are a number of ways people can get involved in the networks and sort of the wider kind of effort to recover meteorites in the UK. The first thing you could do is you could sign up to the UKFAll network mailing list, which is ukfn@imperial.ac.uk. Because Imperial's the other partner of the UKFAll network, so they run our mailing list, and that basically gives out people information about what the network's doing, as well as like a call to arms, as it were, like for volunteers for any potential future searches. Sadly, we couldn't do that this year. We were really hoping, like when we saw a fireball, that we'd be able to message people, say, hey, anyone in the local area, turn up here and we'll all go search for meteorites together. Obviously, that couldn't happen for health and safety reasons. Sign up to your local societies, like either geological societies or astronomy societies. We're in close contact with them, again, about kind of sending out the word for sort of volunteers for search parties. There's the UK Fireball Alliance, which is that collaboration of all the camera networks. They have their own website and you can sign up to their mailing list. So that's UKFAll.org.uk. Then even more exciting, if you want to do like straight up citizen science, we developed a free app for Android and iOS called Fireballs in the Sky. So you can just download it from the App Store or Google Play. And for one, it's just a really gorgeous star map. So you can help use it to like figure out where the different constellations are. But also, if you see a fireball, if you see a bright shooting star through the sky, you can use your phone's like inbuilt GPS and gyrometer to go, I saw it up there in that part of the sky and it finished down there. It was 6 seconds long. It broke up into a million pieces and it was green. And I heard a bang. And you send that to us. And believe it or not, we've been able to help triangulate meteorites on the ground in Australia from people reporting the fireball using the app. So like, that adds into this database of observations we've got, and because the phones have got so good now, we're able to do that triangulation. So yeah, you can 100% contribute to even observing fireballs with using your smartphone.
And even, with Winchcombe, there were hundreds of recorded observations, even by people's doorbells. These ring bells where people have little cameras. There's amazing footage of it from those. So it really is just one of the most. Didn't you say it was the most well documented or most recorded fireball event ever, Luke, because of things like that? Yeah.
The most widely reported fireball of all time, which is amazing considering like Chelyabinsk, which is a big fireball that went in and like disrupted a small town in Russia, is a thing. So this was like, because people could see it from the Netherlands to Ireland, all the way up and down the country. And yeah, like even doorbell cameras have got to the stage where they can observe fireballs to such a degree that we can use them to triangulate.
That's absolutely awesome. Incredible. Just kind of moving on from that meteorite that you mentioned in Russia, what is the kind of biggest one that we've ever found on Earth?
That's a really good question. So there's, I guess, two flavors to that answer. There's the biggest one that's hit. And again, this is probably not the biggest one that's hit, it's just the biggest one that I'm aware of. So 65 million years ago, there were dinosaurs, and then they all died. And then the reason for that is there's a whopping great hole in a place called Chicxulub. And that's basically evidence of a large asteroid impact that craters about 180 kilometers across. Probably the asteroid that hit was about the size of a small city. And so that would probably be like the biggest thing that's happened in 65 million years. Don't worry, those things don't happen. They happen very, very rarely. Nothing's coming that size coming near us anywhere soon. I looked this up because I knew this question was coming. There is a meteorite called Hoba that fell in Namibia, and that was 60 tons, and that was an iron meteorite. And so that's, I think, the biggest one that we have in our collections. The biggest one I've seen was the Cape York meteorite, which is 30 tons. So again, massive. And that's on display at the American Museum of Natural History in New York. And what was really cool about that was you saw this like whopping great meteorite that's sitting there, and it kind of looks fine. And then my colleague and friend Sam Alpert, who works there, said, I'll take you backstage. And so I was lucky enough to go underneath. And the amount of infrastructure and like support to keep that thing up and not just falling through the rest of the museum was extraordinary.
Is it an iron, presumably?
Yeah, they're iron meteorites. Yeah. So basically just solid 30-ton lump of iron, nickel, metal.
And the funny thing about those iron meteorites is because a lot of them have crystallized over hundreds of thousands of years in space really slowly, is they get beautiful like crystallization patterns. So there's actually quite a cool market for things like knives and jewelry and stuff to be made out of iron meteorites, because they've got unique kind of crystallization patterns, and they're like kind of ultra strong and all these things. So yeah, super like wild market for these kind of for meteorite kind of as a resource as well, which is kind of bonkers.
Mm-hmm.
Yeah, that's absolutely amazing. I just cannot even imagine what that would be like to see that ginormous meteorite. Like, I'm very envious. I might have to make a trip. We do have some more questions coming. So let's see what we've got. What skills do you think are the most important if you want to become a planetary scientist? What a great question.
So I would say, more than anything, it's about teamwork. As we've kind of mentioned earlier, this Winchcombe recovery has been an international collaboration of people all over the world working together, mathematicians, planetary scientists, meteoriticists, just project managing, which was half the time what Luke was doing, even press people who were kind of, going out there and getting the public involved, And so a big part of it is teamwork. I say an awful big part is resilience. What I mean by that is like kind of being able to bounce back a bit from failure, because if you're doing planetary science, you're really at the forefront of science. You're trying out new things to learn new stuff. And a lot of the time, most of the time, that's going to go wrong. You're going to get it wrong, and you're going to get no results, basically. And that can be really tough. So if you're going to get anywhere with it, you have to kind of be able to push yourself and bring yourself back up for when things go wrong. And it sounds like such a cliche, I do realize, but space is hard, especially, gosh, if you get involved in missions, sending rockets to another planet, rovers to another planet, quite often things like that fail. So you've got to be able to get over that and be able to say, no, we're going to go back next time and pick yourself back up again. That would be my thing. Resilience and teamwork. It's not all about being some kind of genius, for sure.
Thank you. That I like the resilience as a kind of thing that you need to have. I think that's a great. Thank you for saying that. We have one last question from YouTube, and that is coming from Derek Sherlaw again. How frequently do you expect the UKFAll network to be triggered by positive sightings? Is there any way to predict when it's more likely that meteorites will fall to Earth and land on UK soil?
Yeah, so on average, based on cloud cover nighttime imaging for the UKFAll networks and UKFAll Alliance, we would expect one meteorite of a searchable size, so that's anything from the size of your thumb to the size of your fist, to hit UK soil every year. So you get one per year. And that's if we're imaging the whole UK. I say that, and then when Winchcombe happened, we had the day before one landed in France, and then a month later, another one, a daytime fireball, landed again, kind of in a similar kind of area, but a bit further to the south and east, near the New Forest Way. But we sadly didn't recover any of those. But there seemed to be just a whole cluster of meteorite falls in the space of about a month. So we wait for 5 years, and then meteorites become like buses, and we get 2 in the space of a month. But on average, there should be 1 per year that we should be able to go and get. And so now that we've got this UKFAll Alliance set up, everything's kind of working. We've got the lessons learned from Winchcombe kind of set. Hopefully, going forward, as long as we're a bit lucky, we should hopefully get one of these once per year. There are certain meteor showers that seem to have more bright fireballs, like the Perseids and the Geminids, those ones seem to have like quite bright events going through them, so they're more likely to have meteorites at the end. But beyond those kind of rough meteor showers, there's not really like a good way to predict when we're more likely to see meteorites or not.
Wow, thank you so much for that. I could talk to you all day. It's been so exciting, but unfortunately we do have to wrap up. So just one last thank you to both of you for joining our Curious About Festival today from the Glasgow Science Centre. And don't forget, if you are watching, we do have more of this today and tomorrow. So do keep tuned and wait for more exciting science. Thanks for watching, and we'll see you again.